Bismillahirrahmanirrahim. Assalamu alaikum, grade 7. In today's class, the unit 7.6 is going to be discussed about the differences between metals and non-metals. In this chapter, you're going to learn about the metals, non-metals, and the metals and non-metals in the periodic table, the properties of metals and non-metals, and the atoms arrangement in metals and non-metals. Also, the using atoms arrangement to explain the properties. Here I'm going to discuss the basic differences between the metals and non-metals you have already learned in your previous classes. Metals are malleable and ductile, whereas non-metals are neither malleable nor they are ductile. Metals are strong and tough, whereas non-metals are brittle, so they can break easily. Metals are the good conductors of heat and electricity. Non-metals are bad conductors of heat and electricity except for the graphite, which is a good conduction of electricity. Metals are lustrous and can be polished. Non-metals are non-lustrous, they are dull and cannot be polished except for the iodine. Metals are solid at room temperature except for the mercury, which is a liquid metal. Non-metals may be solid, liquid, or gas at room temperature. Metals have high melting and boiling points, whereas non-metals have low melting and boiling points. Metals and non-metals in the periodic table. The elements to the left of the step line, which are blue in color, are the metals, whereas the elements to the right of the step line, which are pink in color, you can see in this picture, are non-metals, whereas the elements which are adjacent to the line, step line, and green in color are metalloids. And metalloids are the elements which have the intermediate properties between metals and non-metals. The properties of a typical metals and non-metals have been shown to you in the following table. The melting and boiling point of metals are high, except mercury, whereas the melting and boiling point of non-metals are low, except for the carbon, which has high boiling point. The appearance of the metals are shiny, whereas the appearance of non-metals are dull. The conduction of electricity in the metals are good, whereas the non-metals are the poor conductors except graphite, which is a form of carbon. The conduction of heat are good in the metals, whereas most of the non-metals are poor conductors except for a diamond, and diamond is also a form of carbon. And other properties are of the metals, they are the strong and bendy, whereas non-metals are brittle. The atoms arrangement in metals and non-metals. In metals, the atoms are arranged in a huge pattern, and the strong forces hold the atoms together. The rows of the atoms can slide over each other, as you can see in this picture. And non-metals elements exist as single atom or as a molecule, and there are the weak forces between an atom and its neighbors. You can also see in the picture that there is a low forces between the atoms, except for the carbon, because carbon is different to other non-metals. Its atoms are joined together in a huge structure, and the forces between the carbon atoms are very strong. Using atom arrangements to explain the properties, the first property is the melting and the boiling points. The melting and boiling points in the metals are high because in their solid states, the strong forces hold the atoms together, and much energy is needed to overcome these forces to form liquids or gases. And most of the non-metals have low melting and boiling point because there are weak forces between the atoms. The property of the strength in the metals are strong because the strong forces hold their atoms together, whereas in the non-metals the strength are weak because there are weak forces between the molecules. The property of bendiness in the thin sheet of metal is bendy because its rows of the atoms can slide over each other, whereas in the non-metals they are not bendy, they are brittle, and you can easily tap it with the hammer. They can break because there are weak forces between its molecules. Now, the questions given at the end of the chapter on page number 89. In the first question, you have to describe only three differences between the metals and non-metals. Whereas in the second question, you have to explain why the metal is bendy and the non-metal is not. You can explain with the help of the property of bendiness. And in the last question, the melting point of the chromium is 1890 degrees centigrade, whereas the melting point of argon is minus 189 degrees centigrade. You have to suggest a reason for this difference, why the chromium has high melting point and why the argon has low melting point. Now move to your workbook exercise on page number 38. In the first question, you have to just shade the non-metals only in this given periodic table. And the second question, you have to complete the table. You have to write the properties of metals and non-metals. And in the third question, this is a diagram given over here in which the atoms are arranged of a metal. And so you have to answer in the part A that why the metals have high melting points and boiling points. In part B, you have to explain why metal is bandy. And in the question number 4, iodine is made up of molecules. Each molecule is made up of two iodine atoms, and at 20 degrees centigrade, iodine is a solid, but its melting point is low. So you have to explain why iodine has low melting point, and in the B part, you have to explain why iodine in the solid state is brittle. In the same class, I'm going to start Unit 7.9 about the naming compounds and writing the formulae. And in this unit, I have taken some portion from your Unit 7.7 compounds. The first portion about the compounds and its properties are from your Unit 7.7, whereas other parts, naming compounds, writing formulae, and interpreting formulae, are from your Unit 7.9. Compounds. Some atoms of the elements join to the atoms of the other elements to form the compounds, and the properties of the compounds are entirely different from the properties of the elements present in it. For example, sodium is a shiny metal and it freezes in the water, whereas the chlorine exists as a green, smelly, poisonous gas. When these two elements join together, they make a compound, sodium chloride, which is a table salt, and you add it to your food. And the property of this sodium chloride table salt is entirely different from the properties of both the elements present in it. The next slides are from your Unit 7.9 onwards. Now, naming compounds. If you have the compounds which consist of both metals and non-metals, so you have to follow the rules to write the name of these compounds. First, you have to write the name of the metal, followed by the name of the non-metal, but change the end of its name to IDE. IDE. Let's take the example. If you have a compound, zinc and oxygen. Zinc is a metal, whereas oxygen is non-metal, so zinc would come first and oxygen later. And oxygen would the name of the oxygen will be changed into oxide. The compound would be zinc oxide. Same as for the sodium and chlorine. Sodium is a metal, whereas chlorine is a non-metal, so the compound would be sodium chloride. Now for the compounds which consist of metals, non-metals, and an oxygen. So you have to follow the rules. First you have to write the name of the metals, which is followed by the name of non-metals, but you have to change the end of its name to 8, ATE. The 8, ATE shows that the compound contains oxygen. Let's take the example. If you have a compound which consists of copper, sulfur, and oxygen, here copper is metal and sulfur is non-metal, so would come first. It would be copper sulfate, ATE. ATE means oxygen is there. And for the second one, if you have a compound which consists of potassium element, nitrogen element, and oxygen element, so potassium is the metal, it would come first, and the compound would be potassium nitrate, ATE. Okay. To name the compounds which consist of non-metals only, you need to know the number of atoms of each element present in the molecule. If one non-metal is there, so mono would be added, and for two non-metals, di is added. For three, tri, and for four, tetra would be added. And the name of the end of the non-metal would be changed to the its end of the name to ide, IDE. So let's take the example. If you have a molecule which composed of one carbon atom and one oxygen atom, then the compound name would be carbon monoxide. For the molecule consists of one carbon atom and two oxygen atoms, so the name would be carbon dioxide. And if you have one atom of sulfur and three atoms of oxygen, so the name would be sulfur trioxide. And if you have two atoms of nitrogen and four atoms of oxygen, the name would be dinitrogen tetroxide. Now, writing formulae. Each element has its own chemical symbols, and these chemical symbols give the formula. To write a formula, you have to follow these rules. You have to write each number to the right side of its element symbol and write the numbers in the small and below the line. Let's take an example of if you have a compound of bromine, you know that bromine consists of two atoms of bromine. So the formula would be Br2, and 2 would be small, and which shows there are two atoms of bromine combined together to form a compound. And for the nitrogen monoxide, which means there's one nitrogen atom combined with the one oxygen atom, so the formula would be NO. And for nitrogen dioxide, which means that one nitrogen atom combined with two oxygen atoms, the formula would be NO2. 2 means two oxygen atom is there. And some compounds do not exist as the molecules, so their formula show the ratio of the number of the atoms present in the compound. Let's take the example for iron sulfide. They are present in the 1:1 ratio. So the formula would be FeS. Fe stands for iron, whereas S shows the sulfur. So the formula of iron sulfide would be FeS. Same for the case of sodium chloride. They are also in the 1:1 ratio. The formula would be NaCl. And for the copper sulfate, uh, the copper sulfate is in the ratio of 1:1:4. So the formula would be CuSO4. 4 means that there is a 4 oxygen atoms. And for sodium carbonate, they are present in the ratio of 2:1:3. So the formula would be Na2CO3. 2 means there are 2 sodium atoms, and 3 means there are 3 oxygen atoms. Now, interpreting formulae. Interpreting means to explain. Formulae show whether the substance is an element or a compound. If a formula includes the chemical symbol of one element only, so the substance is an element. And if a formula includes the chemical symbol of more than one element, so the substance is a compound. Now move to end of the chapter questions given on your page number 95. In the first question, you have to name the elements present in this compound. Like in the copper sulfide, there are two elements, copper and sulfur. So the compound would be copper sulfide. So you have to write the name of the elements present in these compounds. And in the second question, you have to name these compounds. Like in the first one, KCl means K stands for potassium and Cl for chlorine. So the name of the compound is potassium chloride. So you have to write the names of these compounds. And in the third question, there are the formulae of the compounds. So you have to you have to write the number of the atoms of each element present in this compound. Like in the first one, P4, it means there are 4 atoms of phosphorus. Okay. And the exercise on your workbook activity given on page number 41. In the first question, name the compounds made up of the atoms of the elements below. For the first part, magnesium and oxygen. When the magnesium and oxygen elements combine to form the compound, the name of the compound would be magnesium oxide. So you have to do the other parts like this. And in the second question, the compounds below are each made up of atoms of 3 elements. So you have to name of these 3 elements. In the first one, calcium carbonate. Here 8 means which shows the oxygen. So the ratio would be 1:1:3. So it means calcium 1, carbon 1, and oxygen 3. So the formula would be CaCO3. You have to do the other two parts by yourself. Now in the third question, you have to complete the table. In the first section here, the molecule of the compound made up of one atom of carbon and two atoms of oxygen. So the name of the compound would be carbon dioxide because it consists of one carbon atom and two oxygen atoms. For the case second one, the name of the compound is carbon monoxide. So the molecule, you have to write the intersection of the molecule of compound is made up of one atom of carbon and one atom of oxygen. and so you have to do the other two parts by yourself. The question number 4, you have to match the following two columns. In the first column, the names of the compounds are given, and in the second one, the formula is there. So you have to match the name of the compounds with the formula. And in the E, there's a table given below, so you have to complete the table. It's very easy because the name of the compound is written in the very left corner, and hint is given to you in the second column. The ratio of the number of the atoms along with the symbols is there given for you, so you can easily write the formulae of these compounds. Like in first one, potassium iodide, here the hint is given to you that there is one potassium atom is combined to the one iodine atom, so the formula would be Ki. And in case of lithium oxide, here the number of the ratios given to you, two lithium atoms combined with the one oxygen atom, so the formula would be Li2O. Similarly, you have to do the other parts by yourself. Okay, this is all from my side. Thank you for your attention, students.